Testing, mic testing. Is it working? No? No? Okay, yeah. Hey everyone, welcome again to one more session on Qualcomm stuff. I'm with Neil to just go over our traditional Qualcomm BoF, which takes us over what we have done in the past 1 year since last connect, how things changed, status, and what are the new SoCs added, and what is next, what people are working on. So let's go with the slide. Um, so this will be the brief agenda. So we'll talk about different topics where what happened in each area, and then we'll see where things can be improved. So Neil, do you want to go over this one?
Yeah, so it's kind of self-explanatory. Yeah, so it's
Hello.
yeah, it's a patch. What was the name? Oh, the patch.
Number of patches.
No,
in
the
the
sent,
list, yeah.
sent and applied. No, number of patches sent. So patch sets and global count of emails, or including replies. So you can see the actual new patch sent and the activity on the patches. So we can see there's a lot of activity, review, and feedback, and so on. So it's pretty stable for the last 2 years, basically. So there's a lot of activity and a lot of review. So
Yeah, but I think that one thing to notice is like there is definitely a drop in number of patches coming onto the list. So I don't know what is the reason.
Drop in the list? I thought it was
I don't think it's a drop, but yeah.
It just
But I think it's pretty stable. We have a constant way.
anymore. They get merged. That was my question coming actually. That in this, that do we know how many are successfully getting applied? So as a community, are we doing kind of many revisions versus I don't care about much revisions, but if it is like applying, getting accepted.
It's really interesting to know. We can know it because now when you apply, we have the lore link added a message ID, so we can actually know.
Yeah.
We can filter out.
Internal stuff I'm doing is that so we are creating a statistics for AI tool, which you can talk openly. There's nothing hidden there. Is that we are using patches review for that, and we're using the internal patch review to the external patch reviews counts. So we want to say that internal reviews using this AI tools, which are and with some kernel CI kind of stuff, or sorry, 0-day CI stuff. So to see that our productivity kind of, our number of revision in upstream are reducing kind of stuff. So that's the count we are trying to match. So if you can come up with this number, then I can compare that, okay, maybe use that for saying that, okay, these tools are really helping developers to reduce number of revisions because there's trivial mistakes, kind of, they are fixing it internally,
Yeah, I think we can use statistic about acceptance.
Yeah.
Also about number of versions.
Yes.
Could be very interesting. I did it when I upstreamed the 8650. I had a statistic about all the number of versions. Most of it was single version, so it was didn't know initially how much version, but it was the medium was 2.5 versions basically.
That's good.
Yeah,
actually.
really good. Only one or
2.5
two patches took a long time. So, and I think also we could have the delay of acceptance between the first iteration and when it was accepted. So I mean,
Again, it depends when was the first version posted. If it's posted
No,
RC5, then
we
we're
all
done.
understand 2.5 months and all of that, kind of worst case scenario and all of that. So, but just as a community, like this should be also maybe a benchmark that, okay, are we reviewing the patches? Is our maintainers are reviewing the patches? As developers are getting review comments?
But at least we have some review. There is some activity. I mean, there is some review activity for sure. It's not totally flat. So
Yeah.
No, yeah, of course.
Doesn't that hump correlate to one of our projects?
Yes.
Where we
So they announced.
talked about Upstream for a while?
so this was
This is last connect.
I was thinking
8650
This one?
thing here.
This one? Yeah, I think that's
Yeah,
when
that relates to our
announcement
yes,
of
Yeah.
October December time frame. Announcement we start upstreaming in January February time frame.
Yeah, but nowadays I'm expecting with the Qualcomm Linux, the platforms comes abruptly kind of because the way platforms are getting added is not like okay, like new announcement. They are like kind of SOCs which are available. But
Yeah,
Sorry.
this one, yeah.
Wasn't that the big hump there? Wasn't that around the Chrome OS work?
Yeah,
I
this
think
one.
2022.
This one was Chrome OS and 8550 here, and 8650 was here,
8650 is somewhere here.
and
yeah.
here we had 8750.
No,
here.
yeah.
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 So, but it's less because basically
With
most of
8750, we have multiple different initiatives going on in parallel. Well, that's
Yeah.
right. So we have multiple different IoT devices, and we have
Yeah.
your work and many different tech teams at Qualcomm pitching in as well. So and we have even more hobbyists and others doing a vast array of work.
yeah.
So this slide shows the number of platforms and SoCs added over since last connect. So it's pretty much in similar average of 10 to 15.
12 is what
Yeah,
my
yeah.
Linder slide I counted
Yeah.
around 12.
12. Yeah, that's what is reflected
Yeah.
here. So that's pretty stable, I think, across
Yeah.
a couple of years.
And it's cumulative, so yeah.
Yeah, and again the same the number of platforms added into DT and stuff
Yeah.
is around.
Had the same graph.
Yeah.
The morning presentation too.
Yeah, it's near about 50 to 60 new platform. Neil, you want to take this?
So yeah, since last year, we internally do it's still in development. We still do daily and weekly testing on all releases and Linux Next to initially try to boot the most board possible with devconfig and initramfs, so modules, and if possible firmwares, trying to not distribute, not spill out firmware on the internet, so and just try to do a basic run, so CPU performance testing, trying to put CPU in maximum frequency and runs some basic tests, yeah, and shut down. And this permit to find most of the issues. We can detect some with some board and not booting anymore, and big regressions. So at some point we have up to 19 boards with ARM32 boards, but we need to add them back. And everything is integrated with GitLab, so we can have a GitLab UI having all the board, and we have also the DTBS check, so we can actually see the number of DT files that are completely documented or not, and what are the errors for each Linux Next and each release. And if you go to the next slide, we have some statistics about each Linux Next and to see the evolution of the DTBS check. So we are still a long way before having a fully documented, but we went far away. Honestly.
Yeah, definitely. Yeah, I think
We're
now-
still converting stuff, cleaning stuff, documenting stuff.
Yeah, now we are at least 40-45%. I think. Yeah, we still have.
At least
couple
the new platform are correctly documented.
Yeah.
So we still need to fix the old platforms. And the most of the errors come from the Chromebook.
Yeah, the book.
Yeah, because there is weird power
Setup
domain
and yeah.
stuff and
Yeah.
yeah. So
But why these errors are slipping in? Actually, I know the 0-day
No, but
CI.
around
This-
this time they slipped in because that was the only way I could ever take patches.
Yeah.
Okay.
Because we didn't have bindings.
Yeah.
Then I started to be reluctant to take patches where there was binding errors, and now I've stopped taking patches where there are binding errors,
Okay.
except for some very specific cases. So
and you still have errors like since it goes in different trees, you need to wait for the release to actually have a proper documentation and code.
So
No.
even then the DT checker automated won't find it because of dependencies and others.
Yeah, because some trees doesn't go in Linux Next,
I
for
see.
example, so it and not applied in the same time. So you still have some errors. So you won't never have 100% every time, but
So if
the
you
goal
use
is
Chrome, we will be at kind of 80-90 maybe.
yeah, but
In Chrome.
the goal is to for the release to have 100%, for example. Yeah.
Is this based on Rob's board?
Yeah, it's mine. I did it myself. It's the same stuff.
So you will still have, because at some point you need to change something with respect to new bindings or something like that. So for example, EDP compatible. When you get that merged, by default you're not going to have the schema yet, or it goes to a different place. So you will always have something.
Because I screwed up a few too many times, the wrong getter set. So now I rebuild my schema daily from Linux Next, and then whenever you send me a DTS patch, I compare with that schema. So whenever I merge a patch, I check if it's the schemas in Linux Next.
Yeah, but the patch for the schema might not.
Then I don't merge your DTS change. So yes, things that where the fix is to fix the schema. Yeah, that we need to wait for the fix to go in, and then the number will go up.
Yeah,
There's going to be cases where if we screw up the schema, the number will go down.
yeah, it can be some weird stuff like I transitioned the number of hierarchies to 4 on 8050, but the RUB still use RC1, not Linux Next, so
Yeah, and then there are some corner cases where people send me new devices, so a new board where there is like 5 warnings and they are all in the DTSI. Then if that is particularly if that's a hobbyist, I will take that patch. So there's going to be some regressions in the numbers, but on the other hand, when we fix those, it's going to jump up.
Yeah. Do we have a plan to fix those?
Yes, my plan is that we fix it.
yeah, I mean we do.
I think that's
It's okay.
something
I think
probably.
it's a good janitor, kernel janitor, summer project.
Correct. Yeah.
Yeah, but I mean,
That's
as a group, I think we're doing good. We can definitely do the better, but we have a whole bunch of people who are just fixing things up. I mean, people in this room and people outside that are doing a good job, and that's appreciated.
yeah.
My intern is coming, so.
Yeah, that's. I think I was trying to get to a point where we could train.
Coming, so
Yeah.
probably
Yeah,
good.
but we have had problems where people are fixing the YAML and causing just a headache on the reviewers. Because it is, some of these errors are there because fixing them is non-trivial.
Yeah, it's more legacy.
So, but like,
Yeah.
how do you then approach? Should we document something which we should be
No,
fixing
each error. For example, I had an error for touch controller on the surface, so I need to produce the proper YAML. But like for a panel, KZ sent a patch 2 years ago. It didn't get applied. I had to completely rewrite the driver implementation to have it accepted. So each win different case.
I agree.
So,
No,
yeah.
I remember some of
No.
the comments someone was starting fixing, and we did from the and got kind of blasted that okay, this is not how it should be done. So maybe that's not our approach. We just blindly go and fix it.
Yeah.
So, but we should then come out of this deadlock that otherwise we document some of the stuff that we should fixing.
Yeah, so you have UI. You can go on the GitLab thing from the CI, and you have every board, and you have proper. You don't need to
Or
run
maybe
it
before
yourself.
fixing, we just send out a comments. Say, okay, this is what we are going to fix it. If you have some opinion, just let us know.
Yeah,
Otherwise, we are going to fix in a standard way.
It's just a matter of fixing it. The problem is that there's a barrier of entry for people to get into writing YAML or writing the bindings.
Right.
And you need a certain, or it takes a little bit of time to
Yeah.
understand how to describe things in there. And I think that's the problem we've had with the attempts of newcomers coming in and just fixing small things. But if someone comes in, understands the problems and fixing them and describing things in the right way, I mean that's good. It's more just of we've had several cases where
Broke.
it was a
Yeah.
burden on the maintainers.
Yeah.
To keep telling the same thing. Yeah.
Yeah, and it's not the problem of DD Meta because they actually review really fast. It's the other subsystems that takes patch really slowly. So
When it comes to speed, it would certainly be nice if the DTS checker didn't take 30 minutes.
It is fast now.
yeah, but
You can run it against one DTB and one schema, so I don't see why.
You cannot run it against one schema, or you can, but that would give the wrong result. But yes, you can run it on one DTB.
DTB.
So that's a huge benefit. But it still is like 30 seconds to run it on one DTB. But on my machine.
yeah, I had to tweak in multi-core with the highest Linaro runner to have like
20 seconds.
2 or 4 minutes to have other boards, but still, it's not immediate.
Maybe go use more Python or something, or this schema. Because one DTB goes very fast on my machine.
Okay.
Yeah, but when you have 300 TTBs,
Last time I measured, it was like 30 seconds.
30 seconds, okay.
But then imagine you do that for all the patches.
yeah, for 300 device trees, it's long.
So
I mean, if the performance is the problem, this is a problem of money, and just
Yeah.
donate AWS 120
No, but-
for that machine. I mean, this is just
No, but this is why I do it daily.
Change the machines, like, very
This
big
is why I do it
boxes. Put that
daily.
in your
We don't need to do
signature
it
yourself.
ourselves.
I don't know, meaning it's that you can just AWS install if it is, I don't know if something Python, which is, then you should write it down in C. I don't know, just to make it fast. Maybe that's
That
it.
maybe
I'm
we.
just keeping that option on table too, right?
I mean,
Why
there
not?
is the inner loop in that Python script runs like millions, hundreds of millions of times. So I think that's one of those things where you shouldn't use Python.
Yeah,
You
that's what I'm
have
saying.
right loops.
And we have
Yeah.
done this in the past in Qualcomm. We had a one Python script which was Elliot rewrote it in the C code just to make that our kernel compilation faster.
And now we have a safe version, so a safe replacement. to
I
C
know,
as
I'm
well.
just throwing an idea. I don't
No,
know.
that's a good discussion to be on. If you want to run CI on a
Yeah.
very regular basis, I think
I mean,
it helps.
one stuff we could only detect DT change and just check the one that,
That
changed,
particular
for
DT.
example.
Yeah.
Yeah,
Are
but
there any other
we still need.
TXT schemas left?
Yeah.
So what's causing the sudden drops in the curve?
Merging stuff, branch updates. So it's
Uh-huh.
due to Linux Next. The
I
the
think
drop
in
is
each
not
of
significant.
those drops, Rob yelled at me, and in the
Yeah.
second drop, that's where I decided to stop taking patches that introduce warnings.
Yeah, because some stuff can break all boards.
Okay.
But one takeaway, I think we should document if you think something we should fix on priority. I think then I can talk about that with the intern. So I'm not with the wandering around like, okay, I'm fixing which I'm not going to get accepted. So maybe we can try sending request to a mailing list. Okay, this is what we are going to fix. Let us know if you focus on something else. Maybe we should talk offline on that.
Changing TXT
Or just fix
schemas
it and
to-
post it?
No,
Yeah,
that
I mean-
approach I can do that too. Meaning I'm not against that.
Mm.
So the problem is the moment you ask people on the list,
Yeah, I
I'm
never
going to
know.
do this, I don't think people
Yeah.
are going to really pay attention to it. That's not the really mailing list culture. You just fix it, post it, and then keep iterating until
Yeah.
it's.
It's okay. I just want my intern to have better experience, but anyway.
So I think one of those jumps up, I think that was when we did some aggregation, where we looked at types of errors, and we saw that, I mean, I don't remember the time frame, but there was like one fix I did, it was one binding change, which fixed an error in all, say, 89, 96 boards or something. So I removed like 1,800 warnings in one commit.
Okay, good.
So doing some sort of grouping, we could get some more information or indication of what to prioritize there.
Yeah.
But yeah, it's
Yeah, maybe we can look at the history, patches history, and do learn something out of from that, I guess. Okay, let's move on. So in summary, I think over last year we have enabled Lenovo XLE platform, which covers multiple laptops. There's a long list. I think I have 20 plus laptops there, but yeah, people are still sending patches there. On the flagship SoCs, we also started upstreaming SM8750, and then on the AR SoCs, there's one SoC SAR2310, which is upstream by Dimitri. There's again community enabling lots of devices, platforms have been enabled. There's still ongoing efforts on adding new devices, mobile phones, clocks.
I have a general comment on clock controller. It's a clock controller, of course, the lines of code is huge, which is of course is a hardware. But is this how we should do? Meaning it's like for every kind of, it's a repeated code, or it's like for everything we are probably say 8750 to 87650. Maybe the clock controller has not changed much, but there's a different file always. But I'm sure some part of tree is got changed.
So we do this for the video CC and the GPU CC. We can aggregate drivers, but for GCC, the change are subtle that like it affects the PLL stuff and the hierarchy. So it's not so easy.
and there's been, so there's all the data.
Yeah.
But then if we look at last year, there's been a number of polishing fixes where we, polish up the code around the data a little bit and made some improvements there. And there is work happening in the space of clock drivers, the non-data stuff. But as it is today, most of those lines of code is just data.
Data, yeah.
And it is
Offsets and
specific.
yeah,
In some cases, the IP block is reused between one platform and another, and then we take advantage of that in the code.
yeah.
So there's the video CC, but I guess for
Yeah.
GCC and
But
these
it's ACC you cannot really
Display
share.
clock controller, right? I think there's some GPU clock controller as well, but that's where
Yeah.
there is some reuse. So
And then also the PLLs are sometimes different. So
Different versions of them.
yeah.
So the PLL code itself is, well, we're starting to get a lot of those, but it is reused.
Okay, in other words, if the hardware was the same, then we could reuse the drivers
Yeah, the same topology has to be
Yeah.
has to have the same
and
topology.
the same offsets.
Yes.
No, I'm not against the code, it's just that I just keep seeing a lot of files and we have like accumulated lot of files of clock drivers now.
But I guess what Brion was saying is mostly data
Yeah.
reflecting the offsets.
Yeah.
It's not the driver content. The driver
It's kind
I
of
think
DT
generally.
kind of stuff, but in a C code
Yeah.
in my view is
Yep.
something like that. I don't know.
Yeah.
That's-
Most of the logic is already like
Yeah.
abstracted
Yeah.
out of the
All
common clock library, and even for the pin control it's the same, right?
Yeah.
Logic
Yeah,
is
you see,
just
pin
a-
control is similar example.
Yeah.
Interconnects as well.
Yeah. Okay.
Yeah, I think it's mostly self-explanatory. There are lots of numbers and here, so this is
Yeah,
what's got added.
It's coverage over all controllers. So
Video
it's,
CC wasn't there.
Yeah.
Yeah.
Video CC is missing. Oh.
it does.
Video
It is.
CC there, yeah. Okay, and then on the power side, one interesting framework which we added was power sequencing framework. This, so just to note, we had this problem from like probably last 10, 15 years, I guess.
20 years.
Yeah, maybe 20 years, I think. And I think this year was very
Yeah,
good.
it's not a problem.
Yeah. Now it's not a problem anymore. Yeah, our landing team did pretty good job in upstreaming this framework, and I think there's still more
I
improvements.
think
to be
someone
done.
else also started using the non-Qualcomm platforms. I saw ST or someone, I don't know.
Yeah, yeah, yeah.
Submitted code for power sequencing framework too.
INX side?
They're using that framework.
It gets used, yeah.
Yeah.
I saw it.
But
Yeah.
to be fair, it only solves half of the problem.
Oh, come on.
That's still improvement.
Okay, sorry. So let me give you an example. The X13S, right? You have a combo chip for Wi-Fi
Yeah.
over PCIe and M.2 connector. Thing is, you have things shared between Bluetooth and Wi-Fi. Bluetooth is over UART. The Wi-Fi is on the PCIe bus. So one of the problem is how do you power up the PCIe before?
It's done. We did it.
Yeah, this is what the power sequencing does.
This is solid.
The thing is, how should I say this? You're aggregating everything into the PMU, but then most of the stuff can be spread between those two devices without.
No, because he basically took the
So
data sheet.
The big problem.
It took the
is
SoC
describe all
and it took the
inputs
entries.
The big problem we have with the way we do it today is that we describe all the inputs to the WCN, and for example the X-Elite things, there is like 15 regulators, but there is not 15 regulator, or there is not 15 power supplies going into the M.2 connector. So given that it is a certain WCN chip, we have the binding saying that there is 15 inputs, but we don't actually know if there is 15 inputs on the M.2 module that we're using. All we know is that there is like 2 or 3. So the binding today represents a guess of what is beyond the M.2 connector. And yeah, so right now we're blocking things because the binding is a guess and it's not complete.
Yeah,
And
but
on top of that,
yeah, but
if you're swapping the card with something else, you can say, I mean, you have to change the DT. So I guess the best way would be if the M.2 connector would be standardized enough, you would describe the slot like unproposed, and then everything on the other side.
No, no.
I know.
Yeah,
So I
Yeah.
think that the
Swapping with-
main thing
I mean,
is like the power sequencing problem was like catch-22 situation. That's got resolved. There is still lots of improvement we could do. I think some of the use cases.
Do power
Yeah.
management and stuff and all.
Yeah.
But
Yeah.
but how I see is that at least we got the core issue solved,
Mm.
and we can actually add incremental things on top of it.
Yeah.
So why don't we do that for XLE then?
What?
Don't remember why. The patches for the power sequencer for XLE, why those were not merged yet? I think there was a point there about
I don't know about power sequencing, but from power control point of view, everything is. At least things are working fine.
Okay.
There were a couple of issues that I fixed with PCI, and right now it's at least stable. There are no race conditions, and we still need to add power management support and different things. That's it.
Yeah. Yeah. The other thing is like we added few regulator supports and RPM HPD supports on different
But
platforms.
neither on this slide or the previous, we got support for clock controllers with multiple power trains.
oh yeah, I forgot about that. Yeah, we just
Yeah.
merged recently.
We didn't run the slides through. Well, to be honest, we missed some of the stuff, to be honest. So, So on the security side and some miscellaneous things, SHM bridge, which was one of the thing which was long pending, that got merged. Wrapped key support, it's mostly there. There are few more pending items, pending patches from the user space side of it. Hopefully that'll get merged very soon. General purpose crypto engine, there's an ongoing discussion, and I'm hoping that that will be, get some good direction. Mini dump, good progress, and we have in-kernel PD mapper which is merged. So there are some regression, but still it's there. Mostly works. I think. Is it fixed? There was some outstanding problem.
There are two regressions reported.
Yeah.
One of them is fixed. The other one is only reported by one person, I think.
Okay.
So I'm looking forward to
Get
see
get
that.
more.
Yeah, but still we found some issues didn't find before. So yeah,
Yeah.
it was a huge.
Yeah. That was
Mm.
good. And then.
So how many times it made in and out? I believe initially kernel driver downstream long back, we wrote this PD mapper in a kernel.
Okay.
Qualcomm wrote it in a kernel, if I remember. And then someone did it in user space, or that's how it happened?
Maybe that was the
I
QRTR
remember
name
it
server?
being in the kernel.
I mean, the QRTR name server got
I'm sorry?
QRouter.
The QRTR name server. Was
No,
like this.
no, I remember one engineer writing this in the
Ah,
kernel,
okay.
and then it went to user space, and then again looks like coming into kernel. So I can dig in some
So-
2015 code, which is, I believe, which is the kernel
CB
implementation.
started working on this, right? PD mapper stuff.
No, 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 this is like,
No, that was the
I'm
PDR.
saying
not
2015.
Oh, PDR, not fire.
the
Yeah.
But
not the
yeah, anyways.
service registry
Yeah.
server.
Okay, anyway.
Yeah, but I think this is at least this removes some of the user space package
It
dependencies.
also removes most of the functionality of why PD mapper is there, but no one has used that functionality in the 10 years or whatever it's been there, so now it looks okay.
What functionality does it remove? Any?
So the purpose of the PD mapper is to inform the system about which PD
PDs.
has what functionality.
Right.
So
Correct.
you can describe, for example, that your modem thing has a Wi-Fi PD.
Correct.
And then the modem can learn on this hardware, should I bring up the Wi-Fi domain or not? And if you then build a product and you bundle that with an, say, a PCI Wi-Fi module instead, you can change the JSON file for that the PD mapper consumed,
Yeah.
remove the Wi-Fi, and then the modem becomes a modem only, and you have your Wi-Fi service. It becomes a configuration tool. But
Yep.
when I looked at that, I couldn't find a case where we actually used
Yes.
that.
Yeah.
So it's probably fine. And when that changes, when we need that dynamic aspect, we'll
Yeah.
have to figure out how to deal with
Yeah.
it.
JSON file was mostly static, and I think
Yeah.
we were reusing all the similar services across multiple platforms.
I mean, for
Yeah.
such use case, you can just disable PD mapper in kernel and use in user space. It still works. So.
Yes.
Yeah. That's a good solution. Yeah.
And for about Qt, which is in progress.
Pardon?
Qt.
QT. Yeah.
QT.
I think that's the. I think we added in
Qt
No.
is
The SMC invoke.
work.
Yeah. SMC
Okay.
invoke.
Okay, yeah.
That's something we missed, I guess.
No, thank you for that. I think there's a lot of good reviews coming on that.
Yeah, I think it took a long time, but I
Yes.
think we are in the right direction, and I think upstream maintainers are able to test it. That's a
Yeah.
good.
Tested it, it works.
Yeah, that's exactly, and that's pretty good. Then we have SPI Multimaster, which was merged. I think the PCI PCI Gen 4 stability patches.
The whole PCI Gen 4 wasn't there before. So
They did pretty good, I think, last year. So ACMI CPU frequency drivers, that's something which was added. Providers, they're pretty, I think, they're across all the SoCs. As and when we add new platforms or new SoCs, that's what.
Yeah, the core stuff was the QoS for interconnect, which was missing. Because now the gap is.
Yeah.
reached.
Do we use it?
Yeah, I added support.
Okay. How do you configure from the user space to?
No, it's in the interconnect driver.
Okay.
Need to add.
Okay, yeah, that's the provider stuff. Pin control, similar range, I guess, on different SoCs. These are like the SoCs which were covered as part of last 12 months.
You missed the K unit test we have in the ping pong.
Oh yeah.
That's good in the
So
level.
that
It's brutal, but yeah, okay, I'll take it.
We should submit to our kernel unit test cases, kind of, and we'll put it in kernel CI,
Oh yeah, no, but that's for someone else to integrate it. Now I have the test case there.
Okay, sure.
So all you need to do is run it. And it works now. We fixed
Mm.
the inconsistencies.
Yeah.
The only trouble was that Johan didn't like the direction we fixed it. He thinks the test case is wrong. So someone would need to tell us if we treated it in the wrong way.
Yeah, and video and camera side, I think this year was good because the Iris drivers
Yeah.
got merged, and that's a big achievement, I guess, to be honest. And they're decoding support right now, but the new more
More is coming.
more is coming.
Yeah.
Yeah.
Encoding as well. is
Encoding
coming.
and
We're waiting for encoding. Yeah.
It's coming.
it's
Yeah.
I think it's
Hopefully.
coming.
We wanted to submit everything together, but you know how it goes.
No,
right?
yeah, no, I mean, it's fine. The first iteration was wrong, first version, because too much. But how they did is fine. They did iterate. They took suggestions. They added
More
yeah.
formats are coming, right? The
Mm.
next one, BP9, HUVC.
I think the overall effort was pretty collaborative, I guess,
Yeah.
between Linaro engineers, Qualcomm engineers,
Yeah.
and multiple people involved in reviewing
no.
and taking feedback constructively. That was pretty good. I think we should do something like that for any new drivers which are questionable.
Yeah.
So next is Canvases.
It's
Yeah.
not questionable.
Pardon?
It's not questionable.
It's not questionable. It was an interesting presentation.
There's
but
nothing
yeah.
much there.
Yeah. So yeah, so that's yeah. There some good changes, and I think we enabled a couple of new platforms there. One of the things what we wanted to work on next is I think what Brian and the team want to work on is TPG support, so that we could actually run the tests, without sensors. Fast RPC. So this is interesting stuff. So fast RPC has been going up and down, and there's not many patches merged since we last met. It's because one of the reason was not able to test the patches. There was not enough user space infrastructure to actually try and test the same patches. So that is something I think Qualcomm is working on fixing and providing infrastructure to do the unit tests as well, and proper smoke test on different platforms. That's ongoing. That's the GitHub version fast RPC library. Yeah, that's about fast RPC. Audio. Right. So there is a bunch of changes in audio. One of the thing is enabling support for 8750 XE, and there was long pending pipewire issues which were due to some latency requirements of pipewire itself. That got fixed now. They are all backported, patches are all backported to stable kernel. And then we also published GitHub repository for the audio topology itself. So there are lots of contributions to the repository. There people were pushing their graphs for the platforms onto there. So that is pretty getting pretty adopted. So there was also some new features on mapping the channels on the soundbar ports. So different ports can have different channel, and there was like a mixture of configurations that was possible with Qualcomm audio. So that got merged as well. Some compressed offload fixes. And we also did the DP support on the DSP side. We still have an open question of integrating full DP end-to-end use case with pipewire, which is a bit challenging because pipewire tries to send the stream even though the DP is not connected. So that's not good, I think. Then it decides that it can't send, and then everything goes down. So and we added few new codecs. You can see, and couple of new work in progress. So we're trying to add new module supports, for example, bass limiter and things like that. Like if you are doing a volume of, you want to don't want to saturate, you just want to limit to some extent. So those kind of stuff is going to be added, and we're working on Opus codec as well as speaker protection. Christoph and other people are doing the speaker protection stuff. Yeah. Display. Above, do you want to?
Okay.
So yeah, so the main,
I think Christoph should be talking about the
yeah, it's the main 72, 70. Yeah.
Yeah. It's recording.
Yeah. So the new SM8750 comes with the new DPU, so entire display stack. So this was significant upgrade from V10 to V12 of this IP block, and this brought several changes and few things. It took a lot of time, and I think all of the things are solved with the fix for the brightness from Abel, hopefully. And the problem is that Dimitri asked to rebase entire patch set on a cleanup, and that his cleanup is not merged since half a year, so this patch set is pending, and Dimitri is one of the maintainers, so I cannot say that. Don't.
There are like 40 patches.
Yes.
Cleanup, meaning Abhinav or someone not reviewed it, or?
Yeah, so his cleanup is waiting for reviews, but it's huge cleanup, so it's also not that very easy. Or maybe there's some disagreement, I don't know, but the DPU is pending on that.
I think why Dimitri is then holding us DPU V12.
Because he can? I mean, that's how maintainers.
Still override it, right? Why not?
No,
Because these patches
on
go
the
on
OM
top
can
of that.
need everything to be reviewed.
Yeah, you need to review
Well,
it,
you
yeah.
cannot hold its cleanup patches with the half an hour, then it's a new feature which is equivalent also going to be useful on the next SoC. Yeah.
Yes.
You can argue whether it's good or bad, but you can always do it because he's the maintainer.
Yeah.
No, but we need to just not accept it, right?
But you are not accepting it. It's Dimitri that needs to accept the patch.
Exactly what I'm saying is that do we have the discussion with him that why you are holding our patches?
So I think that's the last thing we call with Abhinav. He should review it soon. But yeah, we still late
So-
the cycle.
Last 6
so-
months, if he has not made any progress of getting acceptance, then what is the kind of confidence I get that he's going to make progress in next few months? So that's not fair in my view.
Is there
As a
anyone else
maintainer.
who has reviewed Dimitri's patch?
He's not here.
I mean, other skilled people could review it.
I-
For example, Jessica from
Yes,
display
job
team,
to
right?
know.
But
That's not
it's
good
amount
idea.
of effort,
Yeah, we
work,
should try this
so.
earlier and review stuff so we can, yeah.
But
Yeah,
we don't need to
that's
be
not
on
good.
top of his cleanup. I think we can rebuild everything.
Not entirely, because it conflicts. So either I rework everything old way, but this is, so he commented on this that he doesn't want the old way, he wants the new way. This is why, because his cleanup reworks significantly how this versioning of features of this new DPU are handled. And this is significant change in the code style. And so I could rework it to go the other way, but then his cleanup is blocked. And this is what he doesn't want, right? Because basically the patch sets should not be conflicting, they should be logical.
And it's not just your patches, I think June is also having the same problem.
Yeah, June,
Okay.
everything is
There are
reviewed.
like
So,
right patches,
who is taking the action? I don't talk to Dimitri.
No, but,
Well-
so first and foremost, we don't need to talk to Dimitri. Is the patch as well reviewed? Has anyone else reviewed them?
Yes.
Or are we?
Even Dimitri reviewed the patches, isn't it?
No, I didn't.
Our
Qualcomm patches have been on the list for almost more than
Dimitri's
4-5
patches,
months,
has
and
anyone
everybody.
reviewed?
No, this is waiting, so that part is waiting, yeah.
So
There
the
needs to be-
maintainer is waiting for anyone to review them.
Yes.
So anyway, it's too late. It's you cannot send anything after RC6 on DRM. So
Well, you can send a review,
yeah, yeah, yeah.
and then
But
as
it-
soon as the RC1 comes, you can merge it, and then your
Yeah.
stuff can go in.
Yes.
Yeah.
Well, this problem is everywhere in the kernel. We need more reviewers, right? So,
That's
My
what I'm
idea is
saying.
that, but that's all Apple from. So, Bjorn, in case of Quadpack BSI patches, they have been reviewed extensively for the last 4 months, and Dimitri is reviewed, everybody is reviewed. It's not the reviews is lacking, it's that the merge is lacking because
Because Dimitri
maintainer
wants
is busy
his
doing
cleanup
something
in
else.
first, and you're all saying, I want my patches in, and I'm not gonna review your patches that you want first in. You're just waiting for Abhinav to review them.
No,
If you
Abhinav
want
is
to get
reviewed
respect-
all.
Abhinav waits for.
Everybody is reviewed the patches. they
yeah,
are
that
getting
could be
picked up.
solution. Yeah,
That's the question.
yeah.
So
True.
That's one solution. I
That
agree
is
with
his
you.
solution.
No, he cannot say
Yeah,
this
I
is
think
the
that-
solution
yeah.
though.
You got to merge the panel.
That
Me.
is the solution I would like.
Some
to see.
maintainers are better than other. I merge.
Anyway, I
things
cannot review
faster.
his patches because they are a bit. I mean, I could, but yeah, it's need expertise.
Sure, problem is understood. There are
Yes.
a couple of things to do. Yeah,
Yeah.
sure.
Okay, so PCI, I think we got a few support to IPQ 9574, and I think we added interconnect support, bandwidth support.
Yes, the hierarchy support was pretty nice because you can get link up event asynchronously. So you don't need to wait anymore for.
Yeah, I mean, so we actually set up precedents for Google actually here, because Google actually tried to. There is a delay if you know the Resenware PCI driver. So as per the PCI specification, the host driver has to wait for 1 second to detect, to say whether the endpoint has been connected to the device or not. And that 1 second delay is mandated by the spec itself. So we cannot just skip in the driver. So if you have connected a device and within 500 milliseconds or so, you can actually detect the device. But if there is no device connected, you have to wait for 1 second. And Google actually wanted to avoid that. I mean, if you enable the asynchronous probe, that 1 second will be nullified because other drivers can probe in parallel. User space will not get stuck. But then Google even wanted to avoid that, so they always wanted to skip that 1 second delay, saying that their user space will take care of enabling the device, and that they know that there will be no device during probe. And I blocked that change for some time. And then the proper way to fix that issue is by supporting this global IRQ, because this is a hardware specific, Qualcomm specific feature. So this global IRQ has support for link up interrupt. So once the link up interrupt is there, then we will for sure know that when the endpoint is going to be there. Even if you connect the endpoint later after probe, then you'll get a link up interrupt and we go and enumerate the devices. So that way we actually skip that 1 second delay, because we don't need to poll for it, and then we have the link up interrupt. So now the Qualcomm platforms, we don't have this 1 second delay. We properly avoided it. And also one more thing is that it actually added support for enumerating the devices dynamically. None of the Qualcomm SoCs have the hotplug support. So even if you connect any device, it's a plug and play PCI. If you connect a device to the slot, you need to manually rescan it to enumerate the device. Now you link up interrupt. We actually added the rescan code to the link up interrupt code, so it automatically rescans the bus. Now it's actually plug and play. So,
so Wi-Fi, you don't need to enumerate anymore at the end.
Yeah.
That's
so all the devices, once you connect it, it will just enumerate quickly. So that was something we added. And then we added this ICC and OPP bandwidth load support, so that both can be scaled at the correct time. And then we actually added we actually moved the PCI endpoint test from the, standalone test to K-self test. That was one of such thing. And then we also experimented with the Vertio stuff. It's not yet upstreamed, but then we did spend considerable amount of time playing with the Vertio. And we actually made the Qualcomm endpoint enumerate as a Vertio net device to the host machine. And we can actually be able to do all the network transfers over host and endpoint over Vertio bus. That is.
So you can avoid the MHI.
MHI is one. MHI is one way we could actually establish communication between host and endpoint. But then some customers wanted to avoid MHI because the networking maintainer Yakub, he.
I think we have time.
So anyway.
Yeah. It was knocked and you bypass it.
I think, to be honest, we probably have more content to discuss, but I think we run out of 40 minutes now, 45 minutes actually now. So on the PHY side, it's regular, new SoCs, new platform support to the PHY, DT bindings. As Neil was saying that DTB checks is in place to check any failures. UFS support to gear scaling.
UFS team is adding new features to UFS controller, like QoS or gear scaling, to scale the gear and the clock, which is nice. So you can reduce the gear on the UFS lines at runtime, which is a nice feature.
What's this gear mean? Just means speed.
Like
gear.
Yeah, it's like the PCI Express link speed, basically. Yeah, but you don't need gear 5 when you have low clock, so you just get down.
So this is the heat map which gets updated by pull request.
Just to add, this heat map is used by our customers, so please update it. Community contributions are accepted. It's very easy to do. It's been heavily used by our customers, and
visible. And kind of, I would say, Phoronix articles and all of this is creating all kind of good news for us in a way that people are noticing the overwork. First of all, again, though something to improve always, but yeah, this is everybody likes this page. So keep it updated.
So for UFS, so all of the Qualcomm SoCs should have been scoped for this page.
So not all of the SoC, I would say Qualcomm has so many SoCs.
Okay, anything after the
But whatever we are upstreaming it, yes.
Okay.
Yeah.
Yeah.
Too much information, yeah.